Hey everyone, welcome back to another video. Today we're going to be discussing replacement notation, mapping, and just going over some concepts of transformations in math already. To begin with, I'd like to say that mapping notation, it basically shows how a graph has, or how each coordinate on a graph has moved, and the transformations that are going to be applied. So x comma y would be your starting graph before the transformations, or a point on your starting graph for the transformations. And then this, 1 over bx plus h, ay plus k, is going to be your new point on the new graph after the transformation has occurred. Now, replacement notation is just what's going to be replaced in the original equation. So if you had the graph of y equals f of x, and you were to shift it 5 units to the right, you get y equals f of x minus h using replacement notation, where x would turn into x minus 5. But don't worry about that too much. It just basically shows how the function is changed. So if you wanted to write a function out, and if you were to write a function out, not actually demonstrate how the point is changed, then you would use replacement notation. But if you're asked to show, to state the new coordinates of an image point after transformations have occurred, you'd be using mapping notation. So, replacement notation is going to be expressed with x being moved. Replacement notation is just going to be how you're going to replace each transformation in your function. So, x is going to be converted to x minus h. Y is going to be converted to y minus k, and you'll see what that is going to start to mean. So, in this example here, we're asked to say the mapping and the replacement notation. So, what we're going to do is I say the mapping first. So, if our original graph is y equals f of x, notice how x, this x variable here, is replaced with x minus 5. So all I have to say is x arrow is being replaced with x minus 5, and y is being replaced with nothing, because y is going to stay the same. So all we're going to have is y. And that is replacement notation. If you were asked to state the mapping, I'd have to see this equation here. So we have 1 over b x plus h. B right now is currently 1, right? So I'd write it out. We have our coordinate x comma y is going to be transformed to 1 over bx plus h. So b is 1 over 1, so we just have x, and plus h. So our h value, remember, in our last video, we discussed when h is positive, we're going to be subtracting from x. So our h is going to be positive here, and it's going to be h is going to be positive 5. So now, since our h value is positive 5, we can plug that in here. X plus 5, comma, y, because y is going to stay the same. And that would be our mapping. Now, if I were to go one step further and actually state my replacement notation, or if I were to go one step further and state my description, I'd say that we have a horizontal translation 5 units right. Horizontal translation 5 units right. Again, building off the concept from our last video. Remember, h is a parameter that affects the x. So now, similarly, this one is going to be affecting our y. Notice how y, in this case, is going to be replaced with y minus 3. And x is going to stay the same. Now, this would be different if we had y is equal to f of x plus 3, which these two expressions are going to be mathematically equivalent. But in replacement, we want to have everything on one side. So again, we're replacing y directly with y minus 3 to get our equation shown above, right? So we wouldn't say this is y plus 3. We would move it to the other side and have it in terms of y, or have it on the same side as y to actually express it. So if we're asked to state our mapping, again, x is going to stay the same, because x has no change to it. And our y value, if you were to add 3 to both sides, you'd see it'd be f of x plus 3. And from there, you should be able to recognize that plus 3 is our k value. So k value is positive 3. And if it's positive 3, then we're going to be moving 3 units up. So y plus 3. And if we were to look at our mapping, again, we're going to have ay, or x comma y is going to be turned into 1 over bx plus h, and ay plus k. A in this case is 1, so we just write y, and k is positive 3. So we just add that positive 3 on the end there, and that's how we do that mapping for that question. Now this one sort of combines the two. Notice how our y variable already is added to 2, so it's going to be nice to do our mapping, since we can just say our mapping would be y is replaced with y plus 2. And now we could say that our x value is replaced with x minus 7. X minus 7, and you probably should put these in brackets. And that is already done, right? But now if this 2 was on the other side, and it was negative 2, we'd have to make it in terms of y, so we have to add 2 to both sides, and then we could say y is replaced with y plus 2. Or, yeah, y plus 2. So make sure you're doing that for replacement. But now, what I'd say is, after moving the 2 to the other side, we get y equals f of x minus 7 minus 2. Looking at our transformation equation, you'll notice that we don't have an a value, we don't have a b value, but we do have an h value. And our h value, since we're subtracting from x, is going to be positive. So h is positive, and h is going to be equal to 7, positive 7. Our k value is going to be negative 2. So again, all you're doing for mapping is x comma y is going to turn onto the coordinate 1 over bx plus h, a, y plus k. So in this case, we don't have a b value, so we just write x. And h is going to be, we said, was positive 7, so x plus 7. We don't have an a value, so we're not doing anything with that vertical stretch there, so it's just y. And our k value here is negative 2, so we're going to be subtracting 2 from k. And that's how we get this equation right here. Now what I'd like to do is try a question like this. So we're dealing with mapping notation here, since we have an original point, and we want to find the new point, or we have our original graph, and we have our transformed point. We want to find the vertical translation that can be applied to our original point to get this new point. So we're going to be dealing with our mapping notation. Mapping notation deals with points. So 1 over bx plus h, ay plus k. And we're asking what vertical translation. So if we're looking at this, we're only applying our vertical translation. So there's no changes to x. So if we're writing our mapping, our x would stay the same. There's no vertical vertical stretch. So since it's simply just a vertical translation. So our mapping should look like this. X will turn into x comma y plus k. Our final point is 16 comma 7. And if we're applying a vertical translation, our x value is going to be the same between the 2 points, right? All we're doing is we're going to be changing the y. So we can plug in x equals 16 in the original graph of y equals x squared. So we have y equals the square root of 16, and y will equal 4. So our original point on the graph y equals square root x is 16 comma 4, and we're going to end at 16 comma 7. Now you can see the difference from here to here is positive 3. And if you were to envision this point on a coordinate grid, let's say this was x equals 16, and this is 4. All we're doing is we're going to be moving 3 units up. If we're moving 3 units up, then k is equal to 3. So we would have to have a vertical translation 3 units up. So if k is equal to 3, then we can plug that into our equation here. So y equals the square root of x plus k, so plus 3. And if we were to test this out in our mapping notation, we could see that x comma y will be transformed to the point x comma y plus 3, since k is 3. So we're saying our point 16 comma 4 will be transformed into the point 16 comma 4 plus 3, which is 16 comma 7. So this would be correct here. So this would be the equation of the transformed graph, and this would be the transformation that you would actually have to apply to this graph to get that transformation. So what horizontal translation? So we're looking at a horizontal translation this time, and we would have to apply it to the graph of y equals x. So y equals x, or square root x minus h, and we want it to pass to the point 17 comma 8. So again, our mapping notation is going to be x comma y is going to be transformed into, and this time we're going to have an h value, so x plus h, and y is going to be the same, since we're only applying a horizontal translation, not a vertical translation. No stretches or anything. So the only point that's going to stay the same between the two is going to be the y. So I'd say that 8 is equal to the square root of x, and x is equal to 64 from there, which you get from squaring both sides. So our original point would be 64 comma 8. And our final point, after all the transformations have occurred, is going to be 17 comma 8. So we're going from 64 to 17. And in order to do that, if you again would draw this out and envision it, you have 64, and then 8, and then you have 17, 8. So we want to go from here to here, meaning you would have to do 64 minus 17 units left. You'd have to move or horizontally translate 64 minus 17 units left. Off the top of my head, I believe that is 47. So you're moving 47 units left. And again, remember when we're moving left, we're going to be adding to x. So x plus h, and h will be negative. So therefore, h is negative 3, or negative 47. If we were to plug that back into our original equation, get y equals the square root of x plus 47.